We should go ahead and get started, and welcome back. I'm excited for us to move into week 2 of the semester. Our first sort of technical topic of the semester is that of footprinting and reconnaissance. Two terms that are not necessarily synonymous in other contexts, but in the context of our ethical hacking methodology, they are effectively synonymous with each other. The thought being behind this concept is that the question is, what can we learn about an organization or about a target that we're interested in potentially hacking into via what's effectively just publicly available technical and non-technical information about that organization. What can we learn about them just from what's publicly available? And the short answer is quite a lot, is what we can learn about an organization from what is publicly available. So we're about to enter into, really starting today, what I call sort of our steady state schedule for the semester. From now, at least until say week 12, week 13, we'll have a very similar sort of formula to what to expect in class. We'll have our Tuesday lecture, topic continuing into Thursday. We'll have our Thursday attendance quiz, so I look forward to seeing all of you again on Thursday. And then we'll have our corresponding lab with that topic. So lab 1 starts today if you're in section A, tomorrow if you're in B, which is about half of you, and then section C is on Thursday. And just as a reminder, lab attendance is expected, so please come to lab. Please introduce yourself to your TA or TAs if you're in section B, and please just get started on that first lab. There's also associated with each of the topics sort of the related chapters in the 2 textbook references I have available for you on Canvas. Somebody's already asked me, do I need to be reading the textbook? I think it's a light read, so it's not as if I'm asking you to read War and Peace each week or something like that. It should all, after you've looked at the first Tuesday topic lecture that we have, it should all read very familiar to you. It's not going to be breaking terribly new ground. But in case you're going into an upcoming Thursday and for whatever reason, you're worried about that quiz that day, you're not sure what kind of questions are possibly going to be asked about this topic, and we'll usually be a week ahead. So questions about this particular topic I would ask on next week's quiz after we finish this topic. Those book resources are by far the easiest way to get confidence in the type of typically multiple choice or short answer questions or matching questions one would expect to see on one of our micro or macro quizzes. So I had a version of this diagram up at the very end of last week, and we'll keep referring back to it as the semester goes. The idea is that we have this ethical hacking methodology, and as part of it, there's a series of steps that either we as the ethical hacker or someone who's looking to maliciously hack into a network or organization is generally going to follow. Now, it's not set in stone in the sense that we always do step A, then we always do step B, then we always do step C. These are more general phases that one tends to follow, where we would start with this reconnaissance / footprinting stage, and then getting into more sort of active reconnaissance, learning more information via scanning and enumerating the underlying network, to eventually, hopefully, gaining access to one of the resulting systems, maintaining that access, potentially escalating the privilege associated with that access, then potentially covering tracks, and then, of course, doing whatever the intended goal was of hacking the underlying system. For the purposes of an ethical hacking methodology, generally our goal is to determine what is possible, determine what are the weaknesses in the resulting system. So we start with that first step here in reconnaissance, and for the most part, certainly for the next 6 or 7 weeks, in terms of what is going to be coming next in class, we'll really just be bringing back up this diagram. Okay, we'll start with reconnaissance, that's this week. Next week we'll look at scanning and enumeration, and then different ways of gaining access and escalating privilege in subsequent weeks. So we start with this first step, in which our goal is to figure out what type of information can we gain about an organization that is shared publicly. That is what differentiates what we're calling this sort of passive reconnaissance from more active measures that we will be taking in subsequent weeks. What is the company itself, what is the organization itself sharing? Either knowingly or inadvertently, and I think that part is important here. Some things they are intentionally sharing. They're proud of some sort of technical achievement they've made, and so they publish a technical document or press release about a particular technical achievement. They're looking to hire someone with a particular type of technical expertise, so they have a publicly available job posting for that technical expertise. You can learn quite a bit just by reviewing that type of material and doing so in a fairly methodical way. This is all referred to, at least in this context, as passive reconnaissance. It is things that are being provided for us to review. I think we're on pretty firm footing in saying that this is generally considered to be legal activity. If a company has a website, you are allowed to look at the website. If a company, and they're required to, post various public domain records for how they are storing some of the network infrastructure associated with that website, you're allowed to review those records as well. So the kind of things we'll be doing this week in lab, it's actually a little different from what our subsequent labs are going to be, because you're not needing to use that virtualization infrastructure to the same extent as you will in subsequent labs. What we are doing generally this week in lab is perfectly legal to do. And perfectly valid to look at for an organization, what information is publicly available about that organization. It's legal. To what extent it crosses over from legal to perhaps creepy or weird really depends on one's own personal boundaries here. But if we're focused mainly on the organization level for publicly available information, we're on pretty firm ground in saying this is a perfectly valid thing that we are doing here. You'll look at one of your textbooks and it will differentiate between passive reconnaissance and active reconnaissance. When does something stop being passive and start being active? It's a little bit of semantic games, right? I'm typing things into a keyboard, so it's active always in some sense. The distinction made in the first textbook reference is that in active reconnaissance, you're actively doing something that is not meant to be publicly available. So calling the front desk and trying to figure out what office somebody is in or what their phone number is, or dumpster diving and trying to see what information they threw out and put in the garbage. That becomes a little bit more quasi-legal and starts to broach into things like social engineering and other types of attacks, including things like performing network scans. The legality of doing a deep network scan on a public-facing organization is kind of up in the air and not really necessarily something you'd want to have to deal with that ambiguity. But for the most part, this week, we're talking about the passive side of things. What's publicly available? What can we learn from what is publicly available? And as I mentioned, the answer is quite a bit. As we jump into this next topic here, something I do want to mention as we start to really just run through sort of a fast laundry list of the tools that are available for doing what we'll refer to as open source intelligence. There is a lot, and there's a lot of information you'll be able to gather. I think the real challenge that will come in, even starting with Lab 1, is how does one organize that information that you have access to? You can't really, unless you're a lot smarter than me, you can't really depend on your memory, short-term or long-term, to just memorize what you've been learning along the way. You can use sticky notes. I have a sticky note on my laptop right now. That's also not a very scalable approach. So a good habit that if you're not already in, I'd really like you to try it with a good faith effort this semester, is to have a more cohesive, organized, note-taking approach to the lab infrastructure for this class. As you learn something, I want you to log something. And when you look at the Lab 1 document, I hedge my bets a little bit in that document and give you a few different options for how one would want to do note-taking. Any of them are fine. You need some piece of software that you have reliable access to, probably on multiple devices, that allows you to do things like take quick notes, take screenshots, annotate those screenshots, and just have a reference so that you can look back. Again, if it's an hour later, you'll probably have remembered it, but if it's 3 weeks later, you possibly will have forgotten it. Information that you've already learned about the resulting organization or underlying system. So we have various different tools that are possibly interesting for us to use. I'll walk through a couple of examples of maybe how I would attempt to keep track of things. There is no one right way, but as long as you're kind of consciously making an effort to keep track of what you are learning. Again, not just like what you were learning in class and different terms and techniques that we're talking about in lecture, but as you're exploring a resulting organization, your own private network you'll have access to for these 2310 labs we have, being very conscious with your decision to keep track of what you were learning as you go. You'll probably thank yourself later in the semester when you look back at week 2 notes that you took and realize, here's exactly how I did this exact step back in week 2. It hasn't changed in week 15. I have to just do it again or very slightly tweak what I'm doing as I am trying to learn something else about a different system here. So there are a large number of these tools, and the broader term that people use is OSINT, or open source intelligence. The idea is that there's a lot of information that gets collected and analyzed from public/open sources. The term's a little ambiguous in that there's also this concept of open source software, and a lot of the open source intelligence tools one would use would also be open source software. They're related, but they don't mean exactly the same thing. In one sense, it's a piece of software in which I can inspect the source code for that software and can determine how it runs, compile it, run it myself. Here, this is more, a better term, which is sort of public intelligence than really open source intelligence. Things that are available for you to review, to kind of learn more about a system. There's a couple different links I provided here. I can just quickly just bring them up here. One is just a list of tools, and some people work better this way, that here's just a laundry list of URLs for the various tools for different purposes. There's also sort of a graphical explorer of what's effectively the same database. You have to be a little careful when doing any sort of open source exploration of tools and techniques in this general field. Certainly, having a publicly available GitHub repository is a great place to start if such a thing exists. One thing you do want to monitor is the relative age and update rate of any repository you take a look at. Nothing's just more disappointing than taking a look at an open source tool that looks like it does exactly what you need, and you realize the last update was 7 years ago. Some things don't change over a period of 7 years. The kind of things that you want to look for a third-party open source tool probably have changed over the last 7 years. The likelihood of it still working and being quite appropriate for your purposes decreases quite quickly as the age. Well, this one, and I hadn't checked that before now, the README was updated 4 days ago. That's a good sign. And actually, the entire project is the README, so that means this project itself has been updated relatively recently. It's a good starting point for just reviewing the laundry list of potential tools that are available. The OSINT framework is an attempt to provide sort of a navigable graphical hierarchy of different tools for different purposes. As I was looking at some of these, as I was going to be talking about different screenshot tools and what one can do with them, I looked at, well, I'm kind of curious what kind of evidence capture tools they list. Screen capture, well, it lists Fraps. Has anyone used Fraps before? It's really ancient. It's a good tool. It's a good piece of software, but nobody really uses it anymore. So some things maybe aren't quite up to date with this one. I was interested in looking at, if I want to find more information about a username, there's username search engines. And you can check to see for a given username. You have access to it in one context. What other context could that username be available for? There should also be things like, I don't want to click a couple of these, but determining whether a username has shown up in various hacker mailing lists or hacker databases that have been publicly available. So mail blacklist, breach data, good old have I been pwned. Did you have to look at this for 230 at all when you took that class? Have I been pwned? It's a pretty clever way they store this information, so they themselves are not actually storing any of the breached information, but just hashes of the breached information. So you can quickly check, has Ambrino at Iowa State, that's me, been pwned? Unfortunately, yes. Don't look too smug. I'm sure I put any of your personal email addresses in there. I'm sure it'll show up in this as well. The truth is, if you've had an email address for any reasonable period of time used in any public service, it's probably going to show up in one of these data breaches. Just out of curiosity, and I have not reviewed this before, Evite. Who sent me an Evite? Okay, that's great. LinkedIn, well, that's unfortunate. MDPI is a big academic publisher, so I'm found in that. Ticketfly, I don't know why I've been there, and I've been scraped. That's not too terrible. Just one example, though, of this framework as a way of just organizing, visually providing a hierarchy of the different tools that are available and what their purpose could be for. So it is a pretty good just starting place, but it's also just a massive laundry list of tools at the end of the day. So we need a little bit more structure in terms of what can we learn about a target organization other than just kind of randomly clicking around in there and seeing what is available. There's a lot of things we can learn from reconnaissance. This is just a starting place that we will follow today and Thursday in class. We will start with what network information can we learn via these open source intelligence tools. And it may not seem like much at first glance, but as a starting point, it's a very natural way to start to then dig deeper into an organization. So we can learn things about our domains and subdomains, IP addresses and address ranges associated with a domain, and then all the other information that can be found in a DNS record. There are other ways, even via just this sort of passive reconnaissance, of learning things about the underlying technology, at least of a publicly available web service hosted by that organization. Now, there's a little bit of a distinction here that's a little bit clever, that there are resources that themselves do a little bit more of an active scanning and then provide that resource as a publicly, passively searchable database. So they're doing maybe some of the active scanning for you, but the database is then available for you to provide that passive access to. But you can find things about what users potentially are available on a given system. And then depending on the organization, one can learn either absolutely nothing or in fact quite a bit about the organizational structure and information. We can try a couple different examples here. It's one of the things you'll be doing in lab. It's the real pain point, if there is one in lab 1, where we provide an example of everything we want you to do for lab 1 on one domain. And then the request is pick your own domain and basically follow those same set of instructions again. Where it gets tricky, where I would say is potentially a pain point, is some organizations are very locked down and others are less so. And don't stick with something stubbornly if they don't have any publicly available information. Pick a domain, try a couple things. If none of that's working, pick a different domain. There's plenty of organizations, plenty of domains out there to check out. Why it's called footprinting, the ultimate idea is we are developing something of a footprint of our target. What is the overall security posture? I would also say overall public web presence of that organization, and where's our next steps? We learn enough to figure out, once we want to be a little bit more active in terms of exploring the network space, where do we even start? That's the end goal of this step of the ethical hacking process. Show of hands. How do we feel about DNS? Awareness of it? Have heard the term before? I wasn't sure how far back I had to go. For our purposes now, beyond just understanding DNS as a protocol, we really can use it as our starting point for figuring out, for a domain associated with an organization, who actually owns it. How do we go from a name that we type into a web browser to a resulting IP address, plus additional information associated with that domain? So INA, Internet Assigned Numbers Authority, is the global organization responsible for management of the overall pool of IP addresses and domain name assignment. They actually do not do that much directly themselves, but they're sort of an umbrella organization for the various regional internet repositories that manage the IP addresses for their respective region. For us, if we're sticking in the United States, North America, we have the American Registry for Internet Numbers, and that's for the North American IP addresses. Then that is an organization that also then works with the underlying third-party, usually commercial companies that handle the actual domain name registration themselves. So from a domain name, we have to figure out who is the domain name registrant, and typically we can publicly query that information. And from there, we can get information like the resulting IP address or address range, and some other things we can learn about a particular organization. We can use the whois command on the command line, and there's also multiple websites that basically just provide whois for us as a web interface. Depending on who is the registrant and what additional resources are potentially put into domain name and registration security, these things can be more or less partially anonymized these days. This is just whois.do. I think I probably just Googled for a whois lookup. You can have it on your command line. You don't need to use a third-party website for that. But from that, it's a starting place, which is I want to learn more about what would be a safe domain. So iowastate.edu. We can't get in trouble for iowastate.edu. And this is just the whois record for it. And this company is not providing really any extra value add from just querying the same DNS server that we ourselves could do via the command line. But even just from that initial whois lookup, and maybe if I can zoom in a little bit here, you can start to learn a little bit more about the Iowa State organization. You can learn some things about it. That's quite old as far as domain names go. That's actually positively ancient. No risk of expiring anytime soon, so we can't go up and just snag the iowastate.edu .edu domain. We would have trouble grabbing an .edu domain anyway. IP address, plus there's 43 other sites, and we can do a reverse IP address. So if you want to know, at least for the public-facing website, which may not necessarily have much to do with the resulting internal network infrastructure, we have a starting place. This is where we go if we want to learn more about iastate.edu and where it's hosted. IP location says it's Illinois and Chicago. Maybe so, possibly in a data center somewhere. It's most likely that Iowa State contracts out for the actual final hosting of their website, listed as a Microsoft IP block. Nowadays, there's very few companies that have their own large amounts of IP address space, Microsoft being one of them. And other information here, the registrants just across the sidewalk here in Durham Center, the DNS servers of record, and just admin contact and tech contact. This is an office number now, so if we really want to learn more about the Iowa State website, we know where to walk to on campus. That was not as information leaking as I would have hoped. Let's see our brethren to the east. Similar, Amazon address space, so being hosted probably at least in part through the Amazon cloud. Amazon owns a very large percentage of the IPv4 address space these days. University of Iowa, we have an address. Now we have a name. I don't know this person. I'm not going to highlight them too much, but if we now need to figure out more about at least the administrative contact for web hosting at University of Iowa, uiowa.edu, we have a phone number, we have a name, we actually have a starting point for an employee at an organization who has some responsibility, presumably, for their public-facing website. That would probably be an example of something, I don't want to go too far with this, but this is an example of something as I'm looking to learn more about an organization. I've picked, after a couple tries, I've picked uiowa.edu. This looks like something I should probably keep track of. I should record a screenshot of that. I should record the information associated with that. And this is where the various tools we have available would allow us to do this. If you are going to be on your Kali boxes, your primary VMs that you'll be using, I think more so in Lab 2 than in Lab 1, but you'll have access it starting later today. You can just click, I think it's Control-Shift-S, but I think there's no guarantee it's going to work. Let's actually put something on the screen. Let's do, okay, just random nmap command. I think Control-Shift-S would get you your screenshot utility. I always get that confused, and then when you're running with multiple VMs, sometimes the VMs will capture those keystrokes, and other times your native OS will capture it. So you have to kind of try around with what works well for you, and that did work here. This would be, based on this would be FlameShot as your screenshot capture tool. You can kind of just select the screenshot you'd want to save. And the nice thing, and the reason I would say this is a good tool to use, and again, this is just some arbitrary screenshot here. This isn't something meaningful right now that I have here. But let's say I really care about the fact that the MAC address of that particular host was this value. Then maybe I'd want to then annotate that value. And then I can put that in my clipboard, or I think Control-C would have also worked. And the tool I happen to have open up here is just OneNote. This is the Iowa State OneNote that you should have access to through our Microsoft Office subscription. It's fine, right? Anything that allows you to put screenshots in, put in some notes, is going to be sufficient for your purposes. I guess there's some value, I would say, to like, that doesn't look super great yet. There is some value to, there it is, it's just a little slow, to having a cloud-based provider for your note-taking software. I have it actually open over here as well on just my laptop, but let's say I wanted to grab that text as well. There's Control-Shift-C. And probably I'd want to organize this a little bit. Now again, this is different than the sort of lab report you'll also be expected to do. This could very much, depending on the type of steps you're following here, it's a little slow on this remote desktop. This could also serve as a nice starting point, though, for that lab report. I need to capture things like screenshot. I need to record the information I've learned about the resulting system. A not terrible way to get started is to make sure every time I've made a reasonable step forward, take a screenshot, I take a note. I add my own personal notes to what I just did and what I accomplished. Then when it comes time, you've quote unquote gotten to the very end of the lab, and you realize I now need to put together a lab report for this. Well, it's supposed to be in this class quite formulaic, and my hope is it's going to be just a lot more just reformatting of this and or copy paste of things from this into a Microsoft Word document. The hope was that you're doing the exploration, you're learning as you go, you're taking notes as you go, and then the actual report is meant to be very formulaic. And you should know exactly what score you got on the lab as you hit submit on it, even before the TAs have reviewed it. So this is a cloud-based OneNote. Okay, I can edit on this machine a little bit better. I also happen to have it open here on my laptop, and it's just the quick note. You can create custom notes for your lab. You can add your own text to it. This was an initial, however you want to take your own note of what you're doing for these particular parts, so you can review that after the fact and learn more about it as you go. This was taking this screenshot, and on the Kali machine, what we had open was the Whois result on just my local Windows laptop. That would be Shift Windows key S. Should also be able to give you, let's see what I have here. That's, we'll do a rectangular snip versus grabbing the whole screen. Let's say if I just want that information for my particular screenshot, that should get put into a screenshot tool here somewhere, save to clipboard, save it to screenshot.png, which I already had one there. I tend to take random screenshots. Then you have it accessible if you need it later. There's all sorts of tools depending on how clever one wants to get with their note-taking to do things like optical character recognition of the resulting screenshots. I don't know how clever one wants to get at the end of the day. Copy-pasting that into a file doesn't take all that much effort. If it was mountains of text, if it was text after text, you may get some value using something like Tesseract to do OCR on that resulting screenshot to determine what was the raw text of that particular image that I have here. Your mileage will vary with that. I just ran it, just opened it up, reloaded it here. I don't know how well you can see that with the font we have here. Actually, it looks pretty good. So Tesseract did a pretty good job of taking that screenshot, converting it just to text, and having sort of a human readable, writable note that we can then use for further purposes. Was that faster / better than just, grabbing and Control-C, Control-V-ing that text? Well, it depends, and it depends on the resource you're looking at. For this case, probably just copying the raw text would have also worked well. But as you're grabbing these screenshots, as you need these screenshots anyway, that's another tool that may be useful for you to be able to learn more about the resulting screenshot. So going back to this concept, we have these domain records. They are required. One needs a DNS entry to have a publicly accessible website. We have to go from a name to an IP address. Otherwise, people are in the business of having to memorize various IP addresses to know where things are. So we have the DNS, we have this domain name system, and it's organized as a hierarchy with your requests that are passed along until there's a DNS server that is found that can satisfy your request. When I look at top line domains like .edu, .com, .gov, there's going to be usually your primary DNS is going to have the appropriate records for where to get started with that. And then from them, oftentimes for our well-known top-level domains, that same primary name server would also have the records for those. And it'll give you access to, for example, where is iastate.edu. But then from there, if we're now looking at various subdomains associated with iastate.edu, and it's not just a singular website on the iastate.edu domains, then you would need to have the subdomain servers associated with the iastate.edu, which would allow you to then to further query, how do I get to, if it's on a different IP, ece.iastate.edu, allows us to determine where that website would be located. And there's additional information as well. So this is the IP addresses, there's the name servers. If there is mail server on the resource, there's going to be MX record associated with it. I didn't look at it too carefully. Was there any MX record associated with this? I bet there is, and then this particular website isn't necessarily showing it here. Let's look at iowa.edu. Why pick on Iowa State? We have uiowa.edu that we can pick on. That not working. What's going on here? Did I type something in wrong? Okay. So we have our IP address. Wouldn't shock me if they close things down. And things like our mail server information for uiowa.edu. It was there. I don't know why .any approach did not work. So who hosts University of Iowa's mail infrastructure? I don't know if you can read it. Okay. It's Outlook, so Microsoft does. Not terribly surprising, but that's your answer, at least for the primary uiowa.edu mail addresses. There was a time where I think it was much more common that one can learn a lot more via DNS entries, and it's been recognized for really over a decade now that there are security concerns associated with putting certain information directly in your DNS entries. There was this concept of a zone transfer, which is still a valid thing that one can do with your DNS entries, which is we have to have the capability to request that we are copying a DNS record from one server to another server. That is a necessary feature. But what we do these days is we really limit the amount of information, and we limit which other servers can request those transfers. So just through some various searching, I found zonetransfer.me, which is specifically a website that intentionally sets up its DNS, I would say, as insecurely as possible to show what is all possible in looking at a broader defined DNS entry here. AXFR is the request to do an actual zone transfer. And when we do so, we learn there's all sorts of other information that can be found. In fact, the DNS protocol is quite flexible in terms of what records you're allowed to put inside a DNS entry. But for example, beyond just the IP addresses, here we have an example that's likely hosted on Google's domain or Google Suite for Business for the email for that organization, and a lot of other things that one can learn from the resulting DNS entries associated with that particular site. Again, that one was designed intentionally to be as, I wouldn't say insecure necessarily, but as sort of open source as possible for you to be able to peruse what is happening inside those DNS entries. Other DNS entries will be as locked down as possible and you learn relatively little, but at the very least, one has to be able to go from a DNS lookup to a resulting IP address. It doesn't serve its purpose. Yeah, question, sure.
This might be more of a DNS question, but why do they have all this extra information if all DNS does is like convert IP and change the host name back and forth?
Well, that is all DNS does as a protocol, right? So I'm going to repeat the question so we have it on here. Why does all this junk even exist as part of DNS? Well, because DNS has grown to do more than just provide an IP address lookup. If something is wrong with this site, wouldn't it be nice if I have a guaranteed contact information for that? These are all what would show up on that other look as being just text records associated with the DNS entry. So that's kind of the answer. You will find other domains in which there's essentially nothing. Domain, IP address, now go away. And that is valid, that's allowed. And I think historically over time we've gone from being fairly expressive with what's put in our DNS records to being relatively tightened up within our DNS records. But University of Iowa hasn't quite gotten the memo. I don't mean anything by that. If anyone is a strong supporter of the University of Iowa Hawkeyes, I have no ill will towards you or your network infrastructure. We can directly query ARIN, and if that's our regional registry, to determine what subnet and subnets are associated with the domain's primary IP. That's also something that's still valid, maybe less so than it used to be in that, this is happening twice now, uiowa.edu, I shouldn't be required to do, oh, this is an IP address lookup, excuse me. So if I go from the IP address, which I did not copy paste here, I can see what is the domain associated with that, what is all registered with that, to see what are the IP address blocks associated with that organization. That can certainly tell you something about an organization's IP address range. In a lot of these cases in modern web hosting, oftentimes, even if the organization itself has its own extensive network infrastructure, its public-facing web infrastructure tends to be hosted through other providers. It's just a very challenging problem to host in a scalable way websites in the year 2024, and so at least that actual final hosting task is oftentimes offloaded. And you can't, well, I guess there's some hints as to what's happening here with Iowa's IP address. It's part of these blocks that are owned by Amazon here. And we talked a little bit about this in our 2:30 review, and there may be a quiz question about this on Thursday about this. It's part of 54.160/11. How many IP addresses, roughly speaking, are in that block? That one that I just highlighted. /11 is the mask, which is a very small block, or a very large block, or a very small amount of mask for that subnet. So how many bits are remaining to provide IP addresses? We have 32 to begin with. 11 are the mask. That leaves us with 21? Is that what I'm hearing? Yes, thank you, 21. 21 IP address bits available left. So yes, there's quite a few that are reserved for various purposes. Roughly 2 to the 21 IP addresses available in that block, and that's a lot. And so in some sense, this does tell us something. Okay, Iowa website at least, hosted on Amazon Web Services, but so are, well, 2 to the 21 is a pretty large number. So are likely several million other organizations as well, right? But at least we know what's part of that. If something were to happen with that address range, something would likely happen to University of Iowa's web hosting as well. We can oftentimes then also trace the path that a request takes using traceroute command, which is something that's, if it's not installed, it's usually a pretty quick install in various systems. That can tell us certain things, not necessarily the number of hops necessarily being a meaningful metric, but perhaps there's certain weaknesses that we can explore along that path as we are determining how to get from point A to point B. Traceroute is also a utility that isn't quite as useful as I say as it would have been in the recent past. There's a recognition that the type of traffic that traceroute generates is very easy to detect. In some sense, there's not a lot of harm in allowing this ping traffic to kind of proceed across your network, but a lot of places just block it by default now anyway. So what it's essentially doing is it's pinging, give me google.com, and come back after 1 hop. Okay, that's the first location. Now give me google.com and come back after 2 hops. Now after 3 hops, now after 4 hops. And along the way, you're basically learning the various steps it took to get to that location. And there's various websites that do allow you to attempt some sort of geographical trace routing. This is just a random one. The issue with, there's a couple issues with trying to do geographical trace routing or trace routing of an IP address or domain name in this case. First off, there are various databases that attempt to geolocate IP addresses, but there's really no guarantee of any of that. There's historic knowledge about where various servers associated with various IP addresses have been located, but they can move. And so they can move in the short term, they can move in the long term as well. And that any type of visual trace route would have to be taking advantage of one of those databases. There's no sort of magical way to go from an IP address to a location, a latitude and longitude otherwise. And then the flip side of using a sort of third-party website like this is, well, first off, that's not a very useful result, but it's not starting from our location, right? It doesn't necessarily know our location, or it's running the tool somewhere in a cloud service and then reporting the results back. It is likely starting, well, it's likely starting here, and we have a hop here in the United Kingdom somewhere. This is likely a server that this is running on located somewhere over there. So it's not a visual trace route from our location, but we can certainly run traceroute ourselves if I have it installed and get a feel for the various hops it takes to get from us to google.com's primary web server. And in this case, we can try to interpret what we're seeing here. Everything seems good while we stay on campus. I haven't exactly looked at this here, to be honest, so I'm kind of playing it by ear as we go here. This is all hopping through the various Iowa State infrastructure, basically to get out of our network. Then there's internet too, so then there's real internet backbone traveling through what appears to be the Midwest. And then finally, we kind of lose the path somewhere along the way to get to probably a server in California somewhere. Although not necessarily. But you can see, as I say there, not all the hops along the way are going to return valid info. That's kind of happening with hop 15, 20 through 2 through 30 there as well. There is a server there, but there's no reliable way to return the IP address for that particular server. And even if there was, there's really no guarantee that your packets are going to take the same path every time as well. So this gives you an idea of what the basic route is from source to destination. It's really not a direct roadmap, but it gives you a starting point to understand how network may be going from point A to point B. There's more that can be automated for you. This is an example of something I would say is another third party doing a slightly more active reconnaissance, and then it's providing that resource for us to then kind of passively peruse for us. Web spiders are commonly used already by search engines to gather the information that they already need to return results. And there are website spiders specifically just for content. And then there's Netcraft, which is essentially, amongst other things, a web spider that's looking at technical organizational detail of the resulting websites. And there's various ways that it can do so. Those type of approaches we would typically refer to as fingerprinting of the resulting servers, and normally we would require some more direct access to do so. Instead, we use Netcraft, which, just like in a sense Google's web spider, is doing that already for us, and we're perusing the results that are provided there. I have Netcraft open here, and this particular service is their site report, which is essentially saying, what is that site running? Let's look at what iowastate.edu is running. Give it a brief moment here to run. We already talked about that a little bit. It's doing the who is information to begin with, so it's running on some Microsoft cloud services somewhere. Let's see what else we have here. The IP address range associated with it, which we also looked up. So this is kind of providing a combination of a few of the other resources we directly looked at. Has some analytics running on iowastate.edu, and so this is new information. It's a good guess, although not guaranteed. It's running on Windows Azure for the cloud hosting of the iowastate.edu website. If some of you work in ICS, maybe you're already very aware of that. Content management system for Iowa State is Drupal. I don't know if that's necessarily correct, but maybe different subdomains use different content management services. PHP, it says, thinks it's running Drupal. HTML5 wouldn't be terribly surprising. Didn't learn that much about it. Let's see if we do a direct report for our website. So this is those of us who are part of this department. This is ece.iowastate.edu, which I'm positive is running WordPress. So I'll be curious if it's able to detect that or if it thinks it's Drupal. They're not that different, but they are different ways of hosting content. Windows, JavaScript, jQuery, WordPress. Okay, so we've learned something about iowastate.edu's web infrastructure. Running Drupal at the top level domain, at least in our department's website, is you're using a self-hosted version of WordPress to be able to host the website associated with that. That is a type of fingerprinting, right? Just going from knowing that we're interested in ece.iowastate.edu or the uiowa.edu, what do we have now? We have the IP address. We have the IP address range. We have some hint about the underlying technology running specifically on that web server, and at least in one of those cases, we have a very specific point of contact of someone who has some responsibility for the underlying network infrastructure, or at least web infrastructure for that organization. We actually know quite a bit. And I mentioned here that actually manually reviewing the site source itself can also be useful depending on what one is looking for. I think that's probably all what Netcraft is doing. If one were just to view the source or download the source or mirror the source for a website, usually there's various code patterns that emerge that will tell you what web management or content management framework is in place. But oftentimes what we do is locally copy the website directly to explore it more efficiently and directly. That's referred to as web mirroring. something that's gotten a little bit more difficult than it used to be, where we used to be able to just use tools like wget or curl, and we can grab an entire website statically. But now, oftentimes, as websites have gotten more advanced functionality, you really have to have an asynchronous JavaScript model to be able to grab and download all of that content. But there are various utilities, including the social engineering toolkit, which will allow us to build a pretty functional clone of an underlying website. It's not just as easy as grabbing index.html and going from there. You have to grab the corresponding source as well to be able to mirror a website entirely. Let's leave things here for today. We'll jump onto the Wayback Machine on Thursday. Good luck with your labs this week. I'm looking forward to seeing what you explore. I'm looking forward to seeing what breaks also. I'll see everyone on Thursday. Thanks.